Hello and welcome to the 7th session of our playlist where we are trying to learn about agentic workflows using LangGraph. So in the last session we saw how we can interrupt the execution of our graph by adding an interrupt setting while compiling the graph and then using human input to control the flow of the graph basically. In today's session we're going to look at this particular concept called as human modified states. So in the last session, we were just controlling the flow of the graph through the interrupt section. But in this particular session, we'll see how we can actually get inside the graph and act as a node within the graph to update the state and take part actively in the execution of the graph as a human. You can consider it as one step ahead of the previous concept. So in this session, we are going to look at the intuition first and then the implementation. So the intuition for this particular concept is, for example, you have a graph which took an input query and it generated a response. And what you want to do is, at some point in time in that graph, you want to manually update the state if required. We know that currently the states are being updated in the graph through nodes. But what if we want to manually update the state? A requirement for that can be, say that if we got an input as multiply 3 and 6, but we want to change that input to say multiply 3 and 7. How can we do that? How can we add a functionality where we can include a human to basically make changes to the state in the graph? We'll be looking at this very particular example in this session. Okay. So the graph that we are going to design in this session will look something like this. There'll be an initial state and we have added this human node where we are trying to, I'll just mark it over here. We are trying to manually change the state. So in this human node, via this human node, we are trying to enter into the functioning of this graph and act as a node in order to update the state whenever required. Okay. So let's see how it will function. Say that we had an initial state, multiply 3 and 6. Okay. We know that this is a tool based graph where it has a tools node, so we can assume that there are multiplier, addition and division related tools already present in the tools node, and the LLM that we are using is binded with those tools. So say that we provide an input multiply 3 and 6 to the graph. Now before it goes to the human node, it gets interrupted. We know how the interrupt thing works in LangGraph. We have worked with it in the previous session. What it will do is it will stop the execution of the graph right over here and will await some kind of intervention from our side. So what we want to do is, after it gets interrupted, we'll look at this particular input and we will judge if this input is the right one, or is this input the one with which we want to proceed and execute the graph further. Say that if we do not want to use this very input, we can change it manually in the human node. So say that I changed the state from multiply 3 and 6, this was the state, and I updated it to add another state, multiply 3 and 5. We know how state updates work in LangGraph. It gets appended by default. So this state will obviously be looking something like this. You know how it looks like. Messages, and this will be a list, and it will be a string. Oh, my bad. I'm working with it as if it is Python. It's not Python. So this is how it will look like, and what we did was we chose to update this state and we added this new element over here, multiply 3 and 5. Now this will go to the assistant node, and we know that if we provide this particular prompt alongside a system message or without a system message, it will probably consider that this is the updated state, and it will execute multiply 3 and 5 instead of multiply 3 and 6, and it will do a tool call. It will go to tools node, and it will trigger the multiplier tool. That multiplier tool will give out a value 15. Okay, let me just write it again. 15, right? Now again, in our particular graph, you can see that again it is going towards the human node, and we have an interrupt added before the human node. So again, basically it will ask for validation from us. Do you want the graph to move ahead with this particular value, or do you have something else to tell to this graph? Do you have some other kind of input? So you see how the graph has actually become even more dependent on the human for execution. The human is not just controlling the flow of the graph, but it is also participating actively in the graph and updating the state as and whenever required as per our design. So say that if I say okay, go ahead, and we know that how do we say go ahead? We basically say go ahead by calling the graph.stream, graph.stream with an input equals none, and the configuration and all those things are there. You know about that, config and the stream mode. So whenever we provide a none input to the graph.stream, it basically continues with the current state. So the current state is the tool node's output 15. It will move ahead, go to the assistant node, and then there will be no tool call, and it will go to the output state, and the output will look something like the answer is 15, something like that. It will be a natural language response. Cool. Now let's see how we can get this to work in the notebook. Cool. So I've written a small markdown text here for you guys. In the last session, we saw how we can interrupt the graph using a breakpoint and add human input to control the flow of the graph. In this session, we will see how we can use a breakpoint or interruption in the graph to edit the current state based on the human inputs. Basically, in the last session, the human was able to control the flow. We will see how human can actually act as a node in the graph to control the response generation itself. So I'm going to guide you through the code over here. Let me have a sip of coffee, by the way. Cool, recharge for good. We imported the libraries required, and then we defined the 3 tools that we will require for this graph: the divide tool, the multiply tool, and the add tool functions. We registered all of them as tools using the structured tool class of LangChain. Then we defined the tools list. We instantiated the LLM object. We binded the LLM with the tools. And then here is how we created the human feedback node function. You can see that this function is literally doing nothing, right? It is doing nothing because we want to participate and do something for it. That's why it's doing nothing, basically. So we also call it as a no op node. Why is it called a no op node? Because it does not do any operation by default. It only operates on the state. It only updates the state when we require it to do so. So basically it does things manually. It does things manually, and there is no default function over here that updates the state. And then we are defining a system message. You are an assistant who performs arithmetic operation on the inputs. Pretty good. Then we define the assistant node function assistant, and we are updating the state with the system message plus the state messages. And then we are instantiating the builder object, and we are building the graph sequence. So we added the assistant node, we added the tools node, we added the human feedback node. Then we define the edges, start to human feedback. You can see start to human feedback. This is the start node, start, and this is the end. Okay, let me just color it with something else, green, and then end should be red, right? Cool. Okay, then we add an edge from human feedback to assistant, human feedback. This human node is basically human feedback node to assistant node, and then we have a conditional edge over here from assistant to tools condition, so wherever there is a tool call, it will direct our flow towards the tools node, and if there is no tool call, it will straight up go to the end. And then there is another edge which is for the feedback from tools to human feedback, creating a memory object. Now this is the important part. When we compile the graph, we are adding the checkpointer configuration, and we are adding this interrupt before. So we are telling it to interrupt before human feedback. So whenever the human feedback gets triggered, we have to interrupt before that. Cool. We have seen this in the last video as something like this in the last video as well. Now when we stream this graph, now it will get interrupted before the human feedback node, and as we know that this node doesn't have any function, as it is a no op node, it relies on us to do that. So we manually update the state in this step using graph.update state. So I think I showed you in the last video how to update the state using graph.update state, and this is the method which we are going to use in this video to update the state manually as the human feedback node. So here we are starting to execute our graph. Initial state is multiply 3 and 7, and we have configured the thread over here. Then we are executing the graph. Stream mode is values, and pretty basic up to here. Now we know that as soon as we start executing it or streaming it, we will get interrupted over here right before the human node. So we got interrupted, you can see, and the current state is multiply 3 and 7. So let's move according to this, multiply 3 and 7 over here. Right now we are here. Now let me get the state at this particular point. So we know that the current state is just multiply 3 and 7, nothing else. All of this is just metadata, right? We looked at the checkpoint right now. It is multiply 3 and 7. Now whenever the graph gets interrupted, it looks out for some kind of input from our end, from the human end. So here I'm asking for input, update the stage 2, and based on the user input, I'm going to update the state using the graph.update state feature. So here I updated the state. I will run this for you in just a little bit of time, but right now let's see the flow. We update the state and pay attention to this particular parameter as node. So as node, defining as node parameter. Let me zoom in a bit. Yeah, as node parameter with the graph dot update state basically tells it that the human feedback node, this particular node which we have assigned to the asNode parameter node, has updated the state, state. So when we write asNode human feedback, it will consider this update in state as if human feedback node has done it. Okay, so we ran this and it told us that okay, the update has been made. Now let's get the state again. Let's copy this entire thing in our notepad. Let's delete this. Let's see, I'll zoom in a bit. So there is this first state, first message, multiply 3 and 7, which was the default message. On top of that, I've provided this particular message as user input, multiply 4 and 5. So here the current state will be multiply 3 and 7, which was already the input, and on top of that user has provided this input, multiply 4 and 5. It has provided this input using this particular function over here. I will run it for you. Just let's understand the flow right now completely. So the state has been updated to multiply 3 and 7. On top of that, we have appended this message, multiply 4 and 5, 4 and 5, 4 and 5. Now the messages have got appended to each other and they have not been replaced, because I had shown you in the last video that in order to replace a message, in order to overwrite a message, you need to provide message ID. We will be looking at that particular functionality in action in the next video probably, but right now we're just updating the state in the default manner using the add messages reducer in the backend. And then we have the assistant node. So again, I'm getting the state and I saw the state, and then I'm continuing the execution. You know that whenever a graph gets interrupted, we need to continue the execution by providing none as an input to graph.stream. So I did that. Now the current graph execution looks like this. So the state, the updated state or the current state, we know that whenever we provide none as input to graph.stream, it continues the execution from the current state. The current state was multiply 4 and 5. This was done by the human feedback node, and then a tool was called. As we can see, it went to the assistant node, tool was called, and we got a response 20, because 4 and 5 multiplied is 20, right? 20. Now see, again it is trying to go to the human node, and we have added an interrupt feature before human node, so again it got interrupted. We did not get the final response yet. Now I do not want to add anything else or stop the execution, so I again continued the execution with a none as input. So again it continued the execution from the current state. The current state is this 20. So it continued with that 20, went to the assistant node, and then there was no tool call, and then we got the output as the product of 4 and 5 is 20. So we got this output, the product of 4 and 5 is 20, right? This is the end. So this was the working of this particular graph. Now I will streamline a little bit this graph for you guys so that you can understand how we can, how the power of this graph looks like. I've just developed a small little code where I've added a few if-else statements. So again, I'm taking an initial state, multiply 3 and 7, configured the thread, executing the graph. We know that the graph will again get interrupted over here. Now I'm taking the input. Do you want to change the input? If the human responses with yay, then we ask the human for the input. It will provide the input and the graph will get executed. So the graph will get updated and the graph will get executed. If the user does not want to change the input, if the user wants to move ahead with this initial input, he will just type in nay over here. If he types in nay, this else statement will get executed, and the graph will continue the execution from the current state, which would be the initial state in that case, and it will move ahead. And we know that by default, after the first interruption, we are expecting another interruption if the tools node gets called. For that second interruption, again we will ask, do you want to proceed with the response? If the user says yes, then the graph will continue execution. If the user says no, then we will just stop the execution. If it's a little bit for you, like a little bit more for you, then you can just check out this notebook. I will attach the link in the description section. You can run it for yourself and see how it works. Okay, you can play around it a little bit, add new functionalities, do whatever you like. The possibilities are literally endless. All right, now let's see how it works. So first of all, let me execute it again. Boom. So the current state is multiply 3 and 7. Do you want to change the input, yay or nay? Let's change it, yay. Provide the updated input. Multiply 5 and 10 rather, 5 and 10. Now the state has been updated via the human feedback node, as you can see, and it went through the assistant node to generate the tool call, and we got the response as 50 over here because we have given 5 and 10. Now again it is asking me, do you want to proceed with the response, yay or nay? I would say yay. So let's see what happens. Result of multiplying 5 and 10 is 50. So we got this response. For example, if I had selected nay over here, then it would have just printed human stopped the execution over here. And if I had selected nay in the first if else part, it would just have executed with the initial input, which was multiply 3 and 7 and given 21 as an output. So you can play around with it. It is a basic code, you know that, and you can check out the possibilities for yourself. So this was it from this session. Now in the next session, we are going to look at some other techniques, some more techniques of implementing human in the loop, and I'll try to make it the last session for human in the loop because it's getting a little bit boring for me as well to talk a lot about this one topic. We'll be looking at time travel. Alright, so thanks for watching this video, thanks for learning, and bye bye.